Hello students. Today our topic is IC fabrication. So fundamentals of IC technology. What is an IC? An integrated circuit, sometimes called a chip or a microchip, is a semiconductor wafer on which thousands or millions of tiny resistors, capacitors and transistors are fabricated. An IC can function as an oscillator, amplifier, timers, computer memory or microprocessor. An IC is categorized as either linear or discrete depending upon its intended application. So, the basic steps a simple circuit, when fabricated by silicon planar technology, will have the following steps. First, it consists the basic structure of an integrated circuit consists of four distinct layers of material. First layer is p-type silicon substrate upon which the integrated circuit is to be built. The second layer is thin n-type material which is grown as a single crystal extension of the substrate. Third layer is silicon dioxide. It provides protection of semiconductor surface against contamination, and also the selective diffusion of impurities is accomplished by SiO2 layer. Fourth layer is aluminum layer to supply necessary interconnection between components. So the basic steps involved in IC fabrications are wafer production, epitaxial growth, etching, masking, doping, atomic diffusion, ion implantation, metallization, assembly and packaging. So the first one is wafer production. The first step is vapor production. The vapor is round slice of semiconductor material such as silicon. Silicon is preferred due to its characteristics and it is most suitable for manufacturing IC. It is a base or a substrate to entire chip. First, purified polycrystalline silicon is created from the sand. Then it is heated to produce molten liquid. A small piece of solid silicon is dipped into the molten liquid. Then the solid silicon is slowly pulled off from the melt. The liquid cools to form single crystal ingot. A thin round wafer of silicon is cut using wafer slicer. Wafer slicer is a precise cutting machine and each slice having thickness of about 0.01 to 0.025 inches. When wafer is sliced, then the surface will be damaged. It can be smoothing by polishing. After polishing the wafer, it must thoroughly clean and dried. The wafers are cleansed using high purity, low particle chemicals. The silicon wafers are exposed to ultra pure oxygen. So the next one is the epitaxial growth. It means that the growing of single silicon crystal upon original silicon crystal substrate. A uniform layer of silicon dioxide is formed on the surface of vapor. So here epitaxial meaning arranged upon. It is the process of depositing a thin layer of single crystal material over a single crystal substrate. So one could describe epitaxy as arranging atoms in a single crystal fashion upon a single crystal substrate, so there the resulting layer is an extension of substrate crystal structure. Next one is the etching. So selectively removing unwanted material from the surface of vapor. So the pattern of the photoresist is transferred to the vapor by means of etching agents. The part of the materials are protected by this etching mask. So here as already told in the first step, this is called the silicon cylinder is known as an ingot. Typical ingot is about 2 meters in length and it can be sliced into hundreds of smaller circular pieces called wafers. Each wafer yields hundreds or thousands of integrated circuits. The silicon crystal is sliced using a diamond-tipped saw into thin wafers, sorted by thickness. Damaged wafers removed during lapping. Etch wafers in chemical to remove any remaining crystal material. So polishing smooths uneven surfaces. So next one is the masking. With the help of this process, it has become possible to produce microscopically small circuit and device patterns on SI vapors. So, to protect some area of vapor when working on other area, a process called photolithography is used. The process of photolithography includes masking with a photographic mask and photo etching. A photoresist film is applied on the vapor. The vapor is aligned to a mask using photo aligner. Then it is exposed to ultraviolet light through masking. Before that, the vapor must be aligned with the mask. So, photograph lithography involves two processes, namely making of a photolithographic mask and photo etching. So the photo making of a photolithographic mask involves two operations. One is the preparation of initial artwork, and the other one is the production. So photolithography, as we keep on saying the term photolithography, it may be known as photolithography is a technique that is used to define the shape of micromission structures on a wafer. So doping, to alter the electrical character of silicon atom with one less electron than silicon such as boron, and atom with one electron greater than silicon such as phosphorus are introduced into this area. The p-type boron and n-type phosphorus are created to reflect their conducting characteristics. Next one is the atomic diffusion. So diffusion is defined as the movement of impurity atoms in semiconductor material at high temperature. Then the vapors are heated at a temperature of about 1500 to 2200 Fahrenheit. So the inert gas carries the dopant chemical. The dopant and the gas is passed through the wafers, and finally the dopant will get deposited on the wafer. This method can only be used for large areas. For small areas it will be difficult and it may not be accurate. Next one is the ion implantation. Ion implantation is a low temperature process by which ions of one element are accelerated into a solid target, thereby changing the physical, chemical or electrical properties of the target. Ion implantation is used in semiconductor device fabrication and in metal finishing, as well as in material science research. The ions can alter the elemental composition of the target if the ions differ in composition from the target, if they stop and remain in the target. Ion implantation also causes chemical and physical changes when the ion impinges on the target at high energy. So next one is the metallization. It is used to create contact with silicon and to make interconnections on chip. So a thin layer of aluminum is deposited over the whole vapor. Aluminum is selected because it is a good conductor and has good mechanical bond with silicon, forms low resistance contact, and it can be applied and patterned with single deposition and etching process. So the last step is the assembly and packaging. Each of the vapors contains hundreds of chips. These chips are separated and packed by a method called scribbing and leaving. So the vapor is similar to a piece of glass. A diamond saw cut the wafer into a single chip. The diamond tipped tool is used to cut the lines through the rectangular grid which separates the individual chips. The chips that are failed in electrical test are discarded before packaging. Remaining chips are observed under microscope. The good chip is then mounted into a package. So far we have seen what is the process involved in IC fabrication. So let us look into a recap of it. So it involves 9 processes. One is the first vapor production, which involves the first layer of silicon is preferred. Next one is the epitaxial growth. Epitaxial growth produces a thin film of single crystal silicon from the gas phase upon the existing crystal vapor of the same material. Next one is the masking and etching. With the help of this process, it is possible to produce microscopically small circuit and device patterns on SI vapors. Next one is the doping. Doping is nothing but the diffusion of impurities into the silicon vapors. And next one is the atomic diffusion. Atomic diffusion includes diffusion of impurities into the silicon. It is the other technique to introduce impurities into the silicon wafer. It is performed at low temperature. Next one is the ion implantation and isolation technique. Metallization. Metallization is the process in which a thin layer of metal is formed, which is used to make interconnection between the components. Next one, a final step is the assembly and packaging. So after completing all the fabrication process, several chips are ready on a wafer. Each of the wafer using a common method called scribbing and cleaving used for separation, and they can be mounted and attached to a suitable packages. For added info, we have three different packages. One is the metal can package, other one is ceramic flat package, and the other one is dual inline package. Thank you.